Hi, I'm Rachel Livermore here in Melbourne, Australia, and as always, I'm with Dr. Jeffrey Silverman in San Francisco, California.
And today we have a good old friend of mine, Dr. Iair Arcavi, who is a postdoc at University of California, Santa Barbara and the Las Cumbres Observatory. Welcome, Iair.
Thank you very much. It's great to be here.
So today we're going to talk about a lot of different astronomical things kind of mashed all together into one really interesting discovery and set of observations that was announced a few months ago. A collision of some dead stars that rippled the universe, and then we saw it on Earth. So do you want to kind of step us through some of the basics here, Iair, of what we need to know before we get going?
Yeah, so this one discovery actually solved a bunch of problems in astronomy at once and set the stage for a new type of astronomy that we can do. So we're super excited about it. So first of all, let me just say what it is. It's the merger of two neutron stars sending gravitational waves and light, and we caught both of them from the same event.
All right, so we've got these two very dense stars, these neutron stars. They're orbiting around each other. They give off the gravitational waves, which we can detect. Then they crash into each other. Now what happens?
Right, so now you have it's a very messy process. You have a bunch of material flying out. This material is super dense and super hot, and it's flying out super fast at like a third the speed of light or something like that. As it flies out, it starts to cool down, and it forms the heaviest elements in the universe.
So these heaviest elements that you were talking about, this is stuff that people have heard of: gold, copper, uranium, plutonium.
So if you look at the periodic table, which I happen to have in my glass here, the heaviest elements down here in the periodic table, we didn't know where they were made until now. So we see them on Earth, right? The stuff you mentioned, gold, plutonium, uranium. We know they were made somehow in the universe, but we didn't know how. There was a theory that maybe they were made in the mergers of two neutron stars. But now we know that is where they are made, because the light that we saw from the kilonova is from these heavy elements being made.
So, what was your role in this discovery and the observations that went into it?
Right, so we're one of what's called the follow-up teams. So the gravitational waves are detected by the LIGO and Virgo detectors in the US and Italy. And once they detect the gravitational waves, they send out an alert to us, those of us with telescopes who signed an agreement with them ahead of time, that says, okay, we got these gravitational waves. It looks like two merging neutron stars, and it's somewhere over there on the sky, with over there hopefully being a relatively small region that we can look at with our telescopes. So we had set up a program that once they give us an alert like that, our telescopes, which are totally robotic and are pretty much everywhere around the world, so we don't care when this happens, we'll hopefully have a telescope in the dark, we can start pointing our telescopes in that area where they tell us the neutron star happened and look for it. Now, it's a big area, so this time it was about the size of a banana held at arm's length. At the sky. That was pretty much the size, about 30 square degrees. And so we figure out what galaxies are in that area. We send that list to our telescopes, and they start hitting those galaxies one by one, looking for a new point of light that's not there before. And so we were one of several groups to do this, and we were fortunate to be one of the first people to discover the actual kilonova. So there were 6 of us who were observing the same galaxy within the span of like 40 minutes of each other with our telescopes and other telescopes, and we all kind of zeroed in on that galaxy and found that new source of light that later turned out to be the kilonova. And then once that was announced, there were like 70 other observatories that joined in to look at this at all wavelengths.
So this kilonova, was only around for a couple of weeks. The first observations, like you said, multiple groups within less than an hour of each other looking at the same galaxy. So astronomers had to move fast to look at this all around the world. And, really only in the last maybe, 5, 10, 15 years was this really doable because of the internet and social media, right? People were sharing stuff, Slack messages and Twitter and, emails. Like, I love that aspect of it, that people were tweeting out like, oh, go look over there now around the world.
Yeah, that's true. And our network of telescopes here at Las Cumbres Observatory was built exactly for that. So we have 20 telescopes connected to the internet, and we just tell them, observe these galaxies, and it all happens immediately and automatically. So I don't have to go to a telescope or call someone up or ask for favors. We just click a button, and it's all done automatically and quickly. And yeah, that's really, we could only do this with this kind of technology.
And do you remember what the percentage was someone calculated of all the professional astronomers in the world who had their names on at least one of these papers?
Right. So there is yeah. So on the day that this was released, there were about 80 papers that came out at the same time. And one of them was like the Uber paper that has everyone on it. And there's about 3,500 authors on it. Now, about 1,000 of those are the LIGO, Virgo people who do gravitational waves. And a few more hundred are, I think, the neutrino people, because we also looked for neutrinos from this. And then the rest are astronomers using telescopes like us. So, yeah, it was quite a large fraction of the astronomical community was in on this, which was also, we were supposed to keep it a secret, but we totally failed at doing that.
So I want to jump on that because, yeah, people failed at keeping the secret. This has happened many times in astronomy when people are supposed to keep something under wraps and they let it out early. So that is the best evidence that aliens don't exist, because astronomers are terrible at keeping secrets. They want to get the glory of discovering these things. So there's no way that all astronomers have been told by the government to not talk about aliens. So
Hang on,
just want to get that out.
to be a pedant. It's not proof aliens don't exist. It's proof that no one has discovered them and is keeping it secret.
Yes, I misspoke.
That's proof that no alien conspiracies exist.
That's right.
Because we have just proven how terrible we are at keeping secrets, about a merger of two neutron stars. If it were aliens, forget about it. We wouldn't keep that secret.
But I did find it really interesting as someone outside of this field. I was watching this play out on Twitter. Someone published all of their Slack messages in one of the papers. And like the sociological part of it, the like jockeying for position, people trying to make sure they were getting the right amount of credit was really interesting.
Oh yeah. It was a very stressful few months, both because the event was evolving so quickly and because, we all realized this is the only time it's going to be the first ever kilonova and the first ever combination of light and gravitational waves. So you want to make sure you don't miss this opportunity, right? For a lot of us, this might be the most exciting thing to happen in our careers.
And one thing that I think is really cool is that every time we create the technology to detect something that we think might possibly exist, it turns out to exist. And it turns out to be way easier and quicker to discover than we thought it would be. And this gives me a lot of hope as we move into like this era of the next generation of telescopes with JWST, with the big ground-based telescopes, that we're going to find new things that we hadn't even thought to look for, which is pretty exciting.
Yeah, I totally agree. Every time you look at the sky in a new way, you find new things. It's pretty much guaranteed now.
All right, well, thanks so much for joining us, Iair. This is a really cool discovery, and it's nice to hear about it from someone who was there.
Thank you very much.
Cheers.
Cheers.
Cheers.